All right, take two. We are back again doing Advent of Code puzzles in Ruby, just having some fun with it, trying to write some weird code. We had a couple technical issues, so this is a restart here. I am going to quickly read through the puzzle yet again, though we're already all set up in the editor because it was. That's how far we got before I saw the chat telling me that we were streaming at 360p. So that explains the issue we had with the video yesterday. I think when I installed OBS, I was on like cafe Wi-Fi, and it decided to configure things for streaming from cafe Wi-Fi, which is not appropriate given I got a gigabit connection here. All right, let's get into it. So here we are, day 2, Red Nose reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the Red Nose Reindeer nuclear fusion/fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron, and that's a reference to the 2015 Advent of Code. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the reactor. So it goes on to tell us that we have a series of reports, which are on one per line, that contain a bunch of numbers. And so this sample here is 6 reports, each containing 5 levels. And the engineers are trying to figure out which reports are safe. The Red Nose reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. And the rules are to test whether a report is safe. We want to check that the levels are either all increasing or all decreasing, and that any 2 levels differ by at least 1 and at most 3. And then it gives us some examples showing that the first and last are the only safe ones in this list. And then we took a look at our puzzle input, switched over to our editor, got everything set up. Here's our test input, or our input, puzzle input. And it's time to write code in 1080p now, not in 360p. So this one seems relatively straightforward. Like day 1, I'll probably just lean on the enumerable methods pretty heavily. But let's extract out each line into an object. So we can say input.lines will give us each line, and then we'll map those through strip to get rid of the extra white space. And then let's say reports equals. So we'll map these all into some objects. So this is an individual line. And we can take that line, split it on white space, and map it to integers. And then so this is a list of levels. And then we can make, say, a new report. Report.new. The levels. And so let's create a class report. I don't see any really opportunities to do anything really weird with this one, but we can think about it. One of my favorite hobbies is taking code and disguising it as a FizzBuzz solution, which we could do for one of these. Making sure the messages I'm receiving are not about stream quality. All right. All right, so this code should run and produce, I don't know, let's just output reports.count, just because that should be 1,000, and sort of a sanity check here. Cool. That looks right. Next up, let's what we actually want to count is how many of these are safe. So we can define a safe method and run that. None of them are safe. That's expected. So safe is two things. We saw that in our rules here. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least one and at most three. So we can implement that pretty straightforward. We can say all increasing or all decreasing. And what do we want to call this other rule? I don't know what to call that. Safe differences? I don't know. How'd they word it before? Gradual. All right, sure. So we can implement all of these methods that I have to type out because I don't have AI things doing it for me because I'm on my streaming setup. And the AI things can kind of ruin the fun on these, especially for less complicated ones. Sometimes they just tell you the answer. All right, all increasing. So we have this array of numbers, and we can say each cons 2, which iterates over each consecutive pair of elements in this array, and we want to check that it's true that all of them, for all of them, B is bigger than, or we can say A is smaller than B. And we can do the same for each all decreasing, except that it will be the other way around. And then we can do the same for gradual. So we can say that A minus B dot abs. Yeah, Jiggins, yeah. It is one of those ones where I don't even remember the last time I used it in production code. I think I maybe have, but I think maybe writing some weird view code or something I've used it, but it's one of those things that's really handy when it's handy, and then you forget about the rest of the time. So the difference, the absolute difference is that, and we want to say that, or I guess we can use a range here. We can say 1.3.cover. I think that does the right thing. Let's find out. 564. 564, and that is the right answer. Okay, so not really a ton of weirdness here. I don't really know what to do with this. There's not a lot of complexity, but maybe part 2 will offer some more fun. We can refactor this a little bit. Call this like pairs or something. Replace each of these. Make sure that still gives me the right results. Yeah. Yeah, let's call that there. Git commit day 2 part 1. All right, on to part 2. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. More of the above examples reports are now safe. Okay, so that's example before, but we can see that removing 3 or 4 makes it safe. Thanks to the problem dampener, 4 reports are actually safe. Update your analysis by handling situations where the problem dampener can remove a single level from unsafe reports. How many reports are now safe? Okay, that's cool. So for this solution, what I want to do is I want to there are like ways I could do this in just within the report class and make this work, but I think leaning into the sort of the more fun, the flavor of the problem, let's say, I want to implement a report dampener class. Or what was it called? Report dampener? Problem dampener. Problem dampener. And what do I want this class to do? I want to say let's put the problem dampener in between here. So the problem dampener takes the levels now. And what do we want it to do? We can implement safe on it, just to make sure that this code now still runs, but we're going to get 0. That's expected. So we can return true if report new at levels safe. Okay, so that should replicate the original behavior and get us 564 back. It does. But if that's not true, we want to iterate over all the versions with one element removed. And I'm trying to think, is there, there's not a Ruby array or Ruby enumerable method that comes to mind. It's jumping out to me as being like the one that would help us with this. Not cycle. Not permutation. Is there a useful one? Oh, this isn't. Oh, we're getting the new Ruby doc look. What could help us here? I don't think there's a method that just does what we need here, which is fine. We can use delete at mutates it though. Well, we can get around that. All right, let's just open a pry console and try something here. So we have an array of numbers here. Actually, let's make them random numbers, just so we don't mix them up with the indexes. We'll do 6. Okay, so that's a, we can say from we'll store it in a variable, say 0 to a.length. Actually, that's what I want. Oh, not 1.length, a.length. Okay, so that's we want that one. There we go. Okay, so from 0 to 5. Map. Actually, let's do a lazy map on this one, because we don't need to generate all of these if we never actually look at them. And it's a.dupe.delete at, and then let's just 2a it to make sure we get the right thing. Oh, it's, can't use that. Cool. That's not, oh, delete at returns the deleted element. So we need to make sure that we're actually returning the original array. And I hope you can hear my dog drinking. She just got back from her walk. I don't know what to call this. I'm just calling it K for now because we're just testing this. That looks right. Okay, so is this right? This is the array without the first element, the array without the second element, the array without the third element. Yeah, so this is exactly what we want. Cool. All right. It's not beautiful, so we'll probably store that in a private method here. And I'm going to call this variations, maybe? I don't know. And A is going to be our levels. Let's use this, name things a little better. We don't need to call 2A on it. And K is this is a variation in this nomenclature. All right, so that gives us a method that returns an enumerable that iterates, or that yields each variation, or a variation is the original list of levels with one of the levels removed. All right, then we will, all we have to do is variations, is ask if any of these variations is valid or is safe. Port.new variation safe question mark. That seems like it. Did I do it right? Let's find out. 604. That is slightly more. Let's go. There we go. Okay, so cool. We implemented our problem dampener, which depended on the same implementation from the first half, but sort of sat in the middle and tested all the options where we have removed the removed one of the levels. Thank you, Jiggins. Thanks, Velor. Try not to say people's real names, even though I know them. All right, let's commit that, and day 2, part 2. got us. And then we'll move on to day 3.